Hello Algebra, this is a video recap for polynomials chapter, so if you miss a section you can use this to kind of go over it, but I'm going to run through the sections kind of quickly. Also, if you're watching this in spring 2017, some of the order in which my packet will be is a little bit different than your packet, so while I'll run through them, the order might be in a different order, so you might have to like flip back and forth, but all the problems are still the same from 2017 to 2018. So, starting with our first target here, we're simplifying the expression. We want to write an answer in descending order when necessary. So we're really just distributing, and 3 times 3 is 9. Well, it's not really distributing, it's just multiplying in this case. And then when you multiply the x's, you have to make sure that you add the exponents, because we have x to the fourth, which means 4 x's, and one more x here, so this is x to the fifth. In our next term, there's nothing really to do with it. We're just going to rewrite it back down here. And then negative 2 here times this positive 4 would make negative 8x to the 1 and 3 makes 4. So now, once we have done all our multiplication, we combine any like terms, these two x to the fifth terms here, and we get 14x to the fifth minus 8x to the fourth. Now, when you multiply like here, so it's multiplication between these two, that's when you add the exponents. However, when you add, there's addition between these two, that's where we keep our exponents the same. So this x to the fifth and this x to the fifth stay an x to the fifth. And now these two here, this x to the fifth and x to the fourth, for me to be able to add or subtract them, they would have to be exactly the same exponent. And they're different, so they're not like terms, so that's my final answer. Now, if this is the first time you're seeing it and you're seeing descending order just means you're going from the highest exponent down to the lowest exponent. So the order has to be in this order. I can't just switch them. And then the degree is just the highest exponent. So I have a fifth exponent, and I have a fourth exponent here, so my degree is 5. All right, the second problem here, we have some parentheses, but there's nothing in front of the parentheses to distribute. There's like ones here. And since 1 times anything is what it is, I can just ignore the parentheses entirely. And then we're going to just try to combine like terms. So this 6x to the third is going to be my first term because there are no other higher exponents. So since I want to be in descending order, I start with the highest. And then we look for our next highest exponent. So the x to the thirds are done. Now we look at all of our x to the second power. So we get 9x squared. You don't distribute this in all of them. That's something we do later on, but that's only when there's multiplication between them. But this is addition, so we do not multiply. Alright, what's next? We've done our x to the second power, we've done our x to the third, and now we have our x's. So plus 5x, because there's no other like terms. Negative 9 and negative 10 makes negative 19, and my degree is 3. Feel free to pause this and catch up. You should always finish them. So if ever I'm going too fast, because I'm trying to do this under 15 minutes, pause the video, finish your writing, make sure you have any questions answered, and then go back if you need to rewind and rewatch. Alright, for our perimeter problem, we're going to draw a rectangular dog park. Last year it didn't say rectangular, but you have a length and a width, so it better be a rectangle. So we're going to say this is 3x squared plus 9 feet long by 4x squared plus 3 feet wide. So when you have rectangles, this side would also be 3x squared plus 9, and this side would also be 4x squared plus 3. Now, if you're looking for perimeter, that just means the distance around. So all we're going to do is we're going to add everything going around this rectangle here. So 3x squared plus 4x squared is 7x squared, plus now 3x squared is 10x squared, plus 4x squared makes 14x squared. And you can write them all next to each other with a big plus symbol between each of these, because that's what's going on here. Or, just add them around like I did. So 9 plus 3 is 12. Well, we have another 9 plus 3, so that's another 12. So plus 24. And then you circle your answer and move on. That's it. Later on we talk about area. And if it's area, it's length times width. But we'll have a problem for that in a second. So, again, pause it if you need to recap. I'm going to go fast. And I'm going to move on to the next one. So this is where, depending on which year you're looking at it, you may have to switch to another page. So in 2017, this is target 5.3. So that's not the next problem. But I'm going to do this set, so if you have to find it, go find it. So we're trying to find the product we're going to distribute. So these are the ones you distribute. So 2y times y would be a negative 2y squared. You multiply negative 2 times 1, you get a negative 2. Y times y is y squared. And negative 2y times negative 6 makes a positive 12y. So now we're done with the 2y. We've distributed to both parts. And now we're going to distribute the 3. So 3 times y would be 3y. And 3 times negative 6 makes negative 18. And then we add them down. So negative 2y squared plus 15y minus 18. And we are done. It's a trinomial. It's of degree 2. It's in descending order. Everything's all good. Now for problem number 5, you have to do this twice. 2x minus 5 times another 2x minus 5. Usually people do well with this in this chapter, but a lot of times people forget that when you have something squared, it means you have to take it times itself. Once you do that, it's exactly like the first problem. You distribute this in, makes it 4x squared. 2x times negative 5 makes negative 10x. And then you multiply the negative 5 in. You get another negative 10. Sorry. 5 times negative 5 times 2 is negative 10. And then we have an x. And then negative 5 times negative 5 is positive 25. So 4x squared minus 20x plus 25. Number 6 is exactly the same thing. The answer ends up being negative 4x squared plus 36. So if you do distribute that all out, that's what you should get. But the process is the same, so I'll let you do that yourself. All right, moving on. All right, so we've got a square garden, and we're going to extend this 3 feet north. So if it's square, this side's x and this side's x. Go 3 feet north and 3 feet west. So 3 north, and then 3 west. Okay. So this would also be 3, this would be 3, this would be x. We'll put the x on the outsides now. So this would be x here, this would be x here. And so like all of our sides are going to be 3 plus x, 3 plus x, 3 plus x. And then this side will also be 3 plus x. Now, I can write it as 3 plus x, or I can also write it as x plus 3. It doesn't matter which order. But we have an x on this side, and this side here is 3. So it logistically looks like 3 plus x. Now, we want to write a simplified expression to represent the area. Now, perimeter is where you add them all around, but area is where you take 3 plus x, your length, times your width. So again, it doesn't matter if you do 3 plus x or x plus 3, but we do exactly this. 9 plus 3x, and then 3x plus x squared. And we can either do it straight across, or we can do it vertically, where we put the 3x underneath the 3x. Doesn't matter too much. These are like terms. This is my descending order, x squared plus 6x plus 9. That is our final answer. Make sure you combine your like terms in the middle. Make sure you put them in descending order, which means the x squared goes first. If you had this flipped around as x plus 3, then the descending order would come out immediately. But if the original problem is not in descending order, then the final problem won't be unless you put it in descending order. Alright, moving on to the next one. So zero product property, which is target 5.4 in 2017, or in 2018 it's the 5.3 and forward. So zero product property is usually the student's favorite one. You have two products, they both multiply to equal 0, which means either the 2x plus 11 equal to 0, or the negative x minus 7 equals 0. So one of these has to equal 0, because if you have two things that multiply to equal 0, one of them is 0. So now you got to figure out which one. Well, it could be either one. So how do you find the value of x that makes it 0? Is you solve these little equations. Subtract over the 11. So 2x equals negative 11. And then divide by 2. And you get x to be negative 11 over 2. And sometimes students are able to solve these in their heads. I would be leery of that. But if you look at my answer keys, a lot of times you'll just see numbers. You won't see the work that kind of goes behind what we're doing. So in this case, I get x to be negative 7. That's really it. So next one, 4x plus 3 equal to 0. 4x minus 3 equals 0. And you solve each one separately. You get 4x equal to negative 3. Now, the biggest mistake people have is when they divide by 4, they sometimes will subtract 4 because it's 4 times x and they want to make the 4 go away. So you divide by 4 and you get x to equal negative 3 over 4. People don't have problems when it's negative 3/4 and then the other one is being positive 3 over 4. They end up having problems when you have like a 1. So like if it was 6x equals 1, they divide by 6, and a lot of times they'll take, okay, what's 1 divided by 6, and they'll tell me it is 6 when it really should be 1/6. So sometimes people have some trouble with that, but it's usually pretty straightforward. And this one with the squared just means you have 2 of them. So it's 5g minus 3 times another 5g minus 3. And you can do each one separately, just like the last ones, or you can just set one of the 5g minus 3's equal to 0, and then you solve. 5g equals a positive 3 because you bring it over. Divide by 5, g equals 3 over 5. And there are 2 of them, but they are the same. As always, pause this, make sure all of your work is done, make sure that you're completely clear on it before hitting resume. Alright, next one, simplifying radicals. Now, the idea in each one of these problems is you are looking for perfect squares. Like 81 is a perfect square because it's 9 times 9. So 9 squared equals 81, which means that the square root of 81 equals 9. That's what the square root does. So you're looking for sets of 2 of a number, because when you multiply 9 by 9, you get a perfect square. You get which is 81. So how do we do that? It's not quite as easy as this. So like 125 is not a perfect square. So if you have a tree, you look for pairs. Any pairs come out of the root, so the square root of 81 is 9, and so you have to take this 5 that's out here and multiply it by whatever comes out, which is 9. Any pairs come out, anything that's not a pair gets left inside, and we get 45. And that's it. There's nothing left inside the root because there's no pairs, no like extra number here to be left inside. Everything came out. You don't need a root, it's just 45. Alright, and the second one, so we have 100, 10, and 10. So you have a pair of 10s, they can come out. Now, and you have negative 2 times 10, which makes negative 20. Now, some people don't do 10 and 10. Some people do, let's say, 25 and 4. And if you do that, I don't get my 10 and 10. I get 5, 5, and I get 2, 2. But you get a pair of 5s and a pair of 2s. That makes 10. Because you take out a 5 and you take out a 2. 5 times 2 is 10, and 10 times negative 2 is still this negative 20. Easiest version of this is saying the square root of 100 is 10. Like, if we know that, then we're good. Now with the x's, you're still looking for pairs. We have 3 of these x's, and you take a pair of x's out, then anything that doesn't have a pair is left inside. The other way of doing that is you're taking 3 and you're dividing it by 2 because it's a square root. Not this 2 here, but the square root has a 2 that's associated with it. 2 goes into 3 one time with 1 left over, right? So 1 time with 1 left over. All the leftovers stay inside. 2 goes into 8 4 times with none left over. So that's our answer. Alright. When you have negative numbers inside the root, this is like saying what number squared? Something squared gives me a negative 49. And I know the 7 squared gives me 49, and negative 7 squared gives me 49, but what in the world will give me negative 49? There's nothing. No real number. So we're going to say no solution, but we also did mention that just because no real number works, there are imaginary numbers. So 7i would be a solution to this. So I will take either answer for this. It's up to you. Alright, last one on this topic. 125, break it up into 5 and 25. A couple 5s. And then you're looking for pairs. We have a pair of 5s, they come out. Anything that does not have a pair stays inside the root. Leave yourself some space here because now we have to work with the a's and b's. So 2, square root of 2, second root, goes into 3, 1 time, but 1 left over. Same reason with the x's to the third up here in number 12. And then 2 goes into 1, no time, so that b stays put. 2 goes into 22, 11 times, and we're good. Alright, there's going to be another video because I'm out of